Okay, we're going to look at the dynamo hand crank generator, which is also a motor. We're going to run it as a motor because we're supplying the electric energy from the battery. The battery pushes the charge out the positive end here, out the red. It's connected to the red, this red wire, but also then to the black wire here of the device. So it goes into the black. It's going to come out of the red. I'm going to make a connection here with this light bulb. Light bulb has much less resistance than the crank, so the light bulb won't glow on, but we know current has to be going through it. Okay, and as we see, it's going counterclockwise from the perspective of the camera looking at me. Okay, I will now switch the leads around, and we'll see what direction we travel then. So by doing this, the current still comes out of the red of the battery and into the black of the battery. But the red end of the battery is now connected, still through this red wire, but now this red is going to be connected to this red here. Okay? And in this case, I'll go ahead and skip the light bulb. The light bulb actually isn't making a ton of effect because it's a very low resistance light bulb. I'll connect it here. It's going a little bit faster, and now it's clockwise. Okay, so definitely increasing the current will make it go faster. Okay, we could run a simple test of that instead of the battery and show how well it does with just one battery. Okay, you can connect here. Keep this connected now here and here. Bring this out here so we can see it crank. Connect the battery. See, it's a little bit slow. It's hitting my arm, but you can tell it's getting slower. Quite a bit slower. All right. Now we can answer the questions on the motor. Next, we'll look at a video with the generator. All right, now we'll use the hand crank generator as a generator. So if we can look at the bulb, looks like it's shining on. When I turn it on, it definitely is glowing. Okay, and am I connected to the ammeter now? The ammeter will read positive when current is going into the red and out the black. Okay, and negative when it's the other direction. Negative would be the current is going into the black of this and out of the red. Okay? So, what is that? That is positive. So, let's see. I was supposed to go counterclockwise from this perspective, which is this direction. Okay? My current is positive. Right? Positive current. That means the current is going into the red and out of the black, so it's out of the black. If we follow along, the black is connected to the red here, so it's going into the red and out of the black, right? It's going into the red here, out of the black here. Following along, that goes into the red of the device, so it comes out of the black of the device. So into the red, out of the black. This is the opposite direction for current. This direction of current, when we had it connected to the battery, created a clockwise rotation. Now we have, when we crank it counterclockwise, we produce that same direction current, which is into the red, out of the black. Right? When we crank it counterclockwise, we go into the red, out of the black, which is opposite of what we had read. Okay. Let's take one more look at the current reading. As I go around, actually, if I go the other direction now, we'll see now we have a negative value. The current is rather steady. Okay, the bulb is turning on, the current is relatively steady, so we are creating direct current.